Okay, today we're going to cover quadratic formula. Before we do, we're going to first review solving equations by factoring. So we'll look at number one. And number one, again, we need to make sure that everything is set equal to 0. So I will have to add 3 to both sides. That leaves me with x squared minus 4x plus 3, and that's now equal to 0. From here, we do use our box in order to solve this. First term, last term, we multiply those two to get the product, and then the sum is our middle term. So I need two numbers that's sum to get -4 and multiply to get a positive 3. Those two numbers are -1 and -3. So that is what goes back into our box. Now I can find the dimensions of our box. And so when we factor this, this became x minus 1 times x minus 3. That's still equal to 0. And now we split up our factors. We know that x minus 1 has to equal 0, and x minus 3 also needs to be set equal to 0. Now I simply solve both equations. So I add 1 there, so x is equal to a positive 1, and then I add a 3 here to both sides, and x is also equal to positive 3. So those are my two solutions. Same thing moving on to number 2. This time, again, well, I forgot to put the equal to 0, so make sure it's equal to 0. I can go straight to my box here. First term is 2x squared, last term is -5. Their product gives us -10. The sum is the middle term, which is 4. And then I'm looking for numbers that multiply to get -10, right? And that'll sum to get positive 4. And I try 1 and 10, 2 and 5, and no combination of those positives or negatives will be able to satisfy the sum and the product. So this one cannot be factored. Okay, so it can't be factored. And so that brings us to our question right here. What happened when we try to factor number 2? Well, we'll rewrite couldn't be factored. And because we couldn't find a pair to both satisfy the product and the sum. The product and the sum. So we couldn't find that combination, okay? So how do we solve a problem like this? Because this still has an answer, right? It's still going to have a solution. We just can't solve that by factoring. And so this is where we use what we call our quadratic formula. Okay, so anytime we're working with a formula, it's just about identifying the variables and plugging and substituting in. So the quadratic formula is x equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay, and so this is our quadratic formula. You don't have to memorize it. It will be provided for you. But here is the quadratic formula. So I need to know 3 things in order to use this. So out here, let's write to use the quadratic formula. I have to know the values of a, b, and C. Okay, so I have to be able to look at an equation and figure those values out. Okay, so before we start solving this, I want to talk about what is underneath the square root, b squared minus 4ac. So that portion of our quadratic formula is known what we call the discriminant in math. So if we scroll down and go to the back side of this, that's the discriminant. So the discriminant, again, is b squared minus 4ac. This is just the number underneath the square root, okay? So again, we call that the discriminant. The discriminant tells us a few different things. If the discriminant, or the number underneath the square root, is greater than 0, right? So that means this is a positive number, right? Positive number. Then we know that this has two real roots or solutions. Okay. If the discriminant, b squared minus 4ac, the number underneath the square root, is equal to 0, then it has one real root or solution. And then if the discriminant, b squared minus 4ac, the number, again, underneath the square root, is less than 0, that's a negative number. Then it has two, and then there's a typo here, complex roots or solutions. Okay, we'll concentrate on this one more next week. Okay, but it has two complex solutions. Okay, so what does that look like on our graph, right? So what does it mean to have two real solutions, one real solution, or two complex? So on a graph, something that has one real solution, okay, will just intersect the x-axis at one point. So you'll have a quadratic that just intersects, again, the x-axis at one point. So one real root means one like x-intercept. Okay, if we have two real solutions, then we'll have two x-intercepts. Okay, and then this is the tricky one. Okay, we have a whole day dedicated to this. If we have two, again, we're going to cross out real and put complex roots or solutions, then we have 0 x-intercepts. Okay, and so that's how we can look at a graph and say, okay, how many solutions should we have? One real, two real solutions, or two complex. Okay, and so what we're going to concentrate on right now, every time we work the quadratic formula, is first identifying how many solutions and what type of solutions we're going to have. Okay, so that's what we're going to do in 9, 10, and 11. So it says, how can I tell from the equation how many roots we will have? Okay, and it says, remember, find A, B, and C. So again, anytime we're using a quadratic, it does help if it's set equal to 0. I didn't put it here, but all I need to do is figure out what is A. A is -2, right? It's just these numbers right here. B is 12, and C is -18. Okay, and so I'm going to do that for number 10 and 11 right now. So for number 10, A is 2, B is -12, C is 14. And then for number 11, A is -2, B is +12, and C is -22. Okay, so anytime we're using the quadratic formula, this is probably the first thing we're going to do. Identify A, B, and C. The next thing we're going to do is we're going to find the discriminant. Okay, that is the number underneath the square root. in our quadratic formula. That is represented by b squared minus 4ac. And so this is going to tell me whether or not I have 2, 1 solutions or real or complex solutions. So all I have to do is substitute the values that we found into this portion of the quadratic formula. I always use parentheses when I substitute. So b was 12, a was negative 2, c was negative 18. And then I just simply calculate this. 12 squared gives me 144. And then negative 4 times negative 2 times negative 18. I went ahead and did on my calculator. Okay, and I got negative 144. So now I have 144 minus 144, which is equal to 0. And then from our previous part, 0, if our discriminant is equal to 0, then we have one real solution. So when I were solving this, I would know that this has one real solution or root. Okay, I'm going to stop there. We'll solve the rest of the way here in just a little bit. I do the exact same thing for number 10. I find the discriminant. What is b squared minus 4ac? I use parentheses. Okay, I substitute. This time this is negative 12. We have 2. We have 14 as the c. So then, again, I use my calculator, and I did negative 12 squared. That gave me positive 144. And then I did negative 4 times 2 times 14. That gave me negative 112. So now I have 144 minus 112, and that equaled a positive 32. Positive number means 2 real solutions or roots or x-intercepts. And then again, just to practice, b squared minus 4ac is my discriminant. I'm going to substitute using parentheses again. I have 12 as my b, negative 2 as my a value, and negative 22 as my c value. Again, I've already done this, so this is 144 minus 176, which gives me a grand total of negative 32. This time, since it is a negative number, or it's less than 0, I have 2 complex solutions or roots. Okay, and again, we'll hit on that more next week when I get back into class. So that's just finding the discriminant. That helps me understand what I'm looking for when I'm solving these. Okay, so now we're going to concentrate on solving these in their entirety. Okay, so we're back on the first page. We're going to use this entire equation, okay, but I'm going to kind of calculate the discriminant separate before I use the rest of this, right? And so all I have to do is, again, make sure this is in standard form. Remember, standard form is ax squared plus bx plus c. So right now, this is not in standard form. I do have to adjust this equation. So I subtract 5 to both sides, and so now it's equal to 0. Then with this, now I know that my a value is 1, my b value is 4, and my c value is negative 5. I still have to be able to identify a, b, and c. Okay, and then what I do is I'm going to find the discriminant. So I want to know how many and what type of solutions I'm going to have. So I calculate b squared minus 4ac, just like we practiced just now. And that gives me a 4 squared minus 4 times 1 times negative 5. Okay, and so when I plug all of that into my calculator, I can plug it in exactly how you see it fit right here. I get a positive 36. A positive 36 tells me I'm going to have two real solutions. So now I know what I'm looking for. So I continue with my quadratic formula. X is equal to, right, negative b plus or minus the square root of, now we know the discriminant was 36, all divided by 2a, right? And so here's what I need to know. I'm going to substitute still for a and b. B was 4, so I still put a 4 there, and a was 1. Okay, and so I start working this out. I start simplifying. So I have negative 4 plus or minus, I'll talk about that in just a second, the square root of 36. Well, we know the square root of 36 is 6, so now I have negative 4 plus or minus the 6, all divided by, well, 2 times 1 is just 2. Okay, now this is essentially saying negative 4 divided by 2 and 6 divided by 2. So now we have negative 2 plus or minus 3. Whenever I simplify that, I divided both terms by a 2. Okay, now let me talk about this plus or minus. Okay, all this is saying is that I have two problems here. I have negative 2 plus 3, and I also have negative 2 minus 3, hence our two solutions. Okay, that's where we get our two solutions from, the plus and the minus. So I have negative 2 plus 3 leaves me with a 1, so x is equal to 1. And negative 2 minus 3 gives me x is equal to negative 5 as well. Those are my two real solutions. Okay. All right, and so then I'll work number 4 the exact same way, and then I'll try to simplify things for you guys here in just a second. So again, I need this in standard form, so I need to adjust this equation. X squared plus 8x plus 12 is equal to 0. I added 12 to both sides. I now know a is 1, b is 8, c is 12. Again, I can go ahead and find the discriminant. B squared minus 4ac. That's what's underneath the square root. B was 8, a was 1, c was 12. When I plug that into my calculator, I get a 16 as an answer. Again, this tells me two real roots. Okay, just like my last problem. So now I continue with my quadratic formula, right? I had negative b plus or minus the square root of 16, all divided by 2 times a. B was 8, a was 1. And so here we go. I have negative 8 plus or minus the square root of 16 is 4 divided by 2. Again, I do negative 8 divided by 2, which gives me negative 4 plus or minus, and then I do 4 divided by 2, which gives me a 2. And then I split this up, negative 4 plus 2 and negative 4 minus 2. So x equals a negative 2, and x also equals a negative 6. Okay. And then number 5 is set up. I'm work 2 more, 5 and 8, and then I'll give you the answers for 6 and 7, and you can see if you can work it out to get those answers. So number 5, a is 1, b is negative 10, c is 23. Okay, this time I'm going to work it out just a little bit different, right? I'll still find the discriminant, b squared minus 4ac. Okay, I'll still substitute negative 10, 1, 23. When I plug that into my calculator, I get an answer of 8. Okay, and then this is where I'm going to kind of separate. So this tells me, again, 2 real solutions. Okay, and so what I'm going to do is I'm going to use the entire quadratic formula just to show you guys what is going on here. So essentially, I'm going to do 1, right, where we have negative b plus or minus the square root of b squared minus 4ac all divided by 2a. I already have it memorized, but that's why we wrote it down. I took this formula and I just put parentheses everywhere there was a variable, right? And so now I substitute. I go negative 10, because that was a b, a was 1, c is 23, and then a was 1 down here. Okay, and so what I do is I can essentially put all this into my calculator, but I'm going to have to do it twice. Okay, I don't have my calculator on this computer, so I'm just going to use Desmos really quick. But again, you would use your calculator in the same fashion, right? So the first thing I do is I do want a fraction, and I'm going to do negative b, right? So it was, let's see here, negative 10, and I just, the exact same way I wrote it down is how I'm going to type it in. And so the first time I'm going to do plus. I can't do a plus minus, okay? So I do negative b, which was negative 10, plus the square root of negative 10 minus 4 times a, which was 1, times c, which was 23, all divided by 2 times 1, okay? And I get undefined. I plug everything in correctly. I shouldn't have gotten undefined. Oh, that's where I messed up. I forgot the square right there. Okay, and so when I plug that in, I get an answer of 6.41. So this is one of my answers. So x equals 6.41. So we'll just say approximate, right? X is approximately equal to 6.41. And then I know that x is going to be an approximation again, and I have to do this once again. And look, I take the exact same equation, and the only thing I change is the plus that was in front of the square root, I change to a minus. And so that's how we get 2 solutions. Okay, and so that's the only difference. And so my second answer is about 3.59. Okay, so 3.59. So as long as I understand how to plug this in, then my calculator is a useful tool, right? Okay, I'm going to do that same thing with problem number 8. Okay, so problem number 8, again, I have to adjust. I need to subtract 4 to both sides. After I adjust, I have 4x squared plus 8x plus 3 is equal to 0. A is 4, B is 8, C is 3. And then if I want to do that, how I just worked it out, I'm going to do negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, and I substitute my values. B is 8, b again for 8, a is 4, c is 3, a is 4. Today, most of our problems have 2 answers, or all of them, I believe. And so now it's just a matter of me plugging this into a calculator. So again, get a division, negative b, which was 8, plus the square roots of b squared minus 4 times a, which was 4, times C, which is 3, all divided by 2 times A, which was 4 again. So I get negative 0.5 as one of my answers. I copy and paste this just like you would also on your calculator. Change that plus to a negative or a minus, and we get another answer of negative 1.5. So x equals negative 0.5 and negative 1.5. Those are my two solutions. Okay, so I want you guys to practice 6 and 7 using the quadratic formula, of course. The answers for number 6 are 1.5 and negative 5. So see if you can get those two as answers once you do it. And number 7, we should get a final answer of 8 divided by 3 and 1. So just make sure like 8 divided by 3, right, is that decimal, 2.6 repeating. Okay, but I just left it as that. All right, so see if you guys can finish these notes and get those two as an answer.